video, page 349. Let's go ahead and get started with this video. Numbers 11 through 37, the directions say to simplify the expression. I'm going to go a step further and say that probably, I'm going to take the word probably out of there. That means we do not want negative exponents, okay? Alright, here we go. Problem number 11. Notice we're multiplying like bases, a base of 2 and a base of 2. When you're multiplying like bases, you write the like base once, and you add the exponents. 3 plus 5 is 8. Now with the calculator, or you can probably do it in your head, 2 to the 8th power is 256. So the answer is 256. Number 13. We have a fraction times a fraction. Now normally, pretend this was 2/3, okay? Normally I would suggest that you first simplify by taking this exponent and multiplying it through like I've taught you to do. And the same thing with this exponent here. However, if you'll notice, we have like bases, okay? So we're multiplying like bases. Base is 1/2, base is 1/2. So when you're multiplying like bases, remember, you write the base once and you add the exponents. 2 plus negative 2 is 0. Well, anything to the 0 power is 1. So 1/2 to the 0 power is 1. Number 15. Okay, notice we're multiplying like bases. My base here is x and my base here is x. Whenever you're multiplying like bases, write your like base once and then you add the exponents. 4 plus negative 2 is 2. So the answer is x squared. Okay, x squared. Number 17. Now this problem here is an example. Notice we do not have 4 to the 3rd times 4 to the 2nd. In other words, we don't have two bases. Okay, we have one base with an exponent, and then the entire thing is being raised to another exponent. So we have a power being raised to a power. When that happens, you multiply the exponents. 3 times 2 is 6. Then with a calculator, you would type into your graph for 4, then arrow, then 6, then enter, and you'll get 4,096. 4,096. Okay, moving on to number 19. And that's the wrong button, so hold on one second. Okay, notice here, students, we have one base x with a power, and that power is being raised to a power. So when you have a power being raised to a power, you multiply. Negative 3 times 5 is negative 15. Okay, now, we do not want a negative exponent, so remember, x to the negative 15 is really over what? 1, okay? You can put anything over 1. Now, the power of the 1 is 1. That's a positive 1. So we do not need to move this. However, the power of the x is negative 15. So we need to move this to the bottom so that we have no negative exponents in our final answer. So, what do I already have in the denominator? A 1. What am I bringing down to the denominator? An x. The 15 becomes positive. There's nothing left up top, so what do we have to put? A 1. So my final answer is 1 over x to the 15. Students, if you have x to the 15 over 1, you can definitely drop that 1 and just put x to the 15. But if you have 1 over x to the 15, the 1's up top, you cannot drop that 1, okay? You have to keep that. So your answer is 1 over x to the 15th power. Alright. Moving on to number 21. Okay, here we have a bunch of powers. Now remember, if this was 2 terms, you could not do this, okay? But it's 1 term. They're multiplying here. So it's 1 term, okay? We have some exponents or powers being raised to a power. Alright, so here we go. 4 times whatever powers are being raised to a power, you multiply. 4 times 3 is 12. 4 times 1 is 4. That's it. What else can we do, guys? There's no negative exponents. If we had a negative exponent here, then we would bring this x to the negative 12 down to the bottom and make it x to the positive 12. But we don't have that. We have just x to the 12th y to the 4th. Now if we had x to the 12th, x to the 4th, then we x to the 16th, but we don't have that, okay? So we are finished. That is the answer. Moving on to number 23. Okay, now we have here's about negative 3 to the 1 power being raised to the second power. Now be careful here. Please be careful. Listen to me carefully. This negative 3 is inside the parentheses. This 2 is on the outside. So 2 times negative 1 is negative 3 to the second power. Now, I put that parentheses because, let's just talk about this for a second. Forget this problem for a second, okay? Come down here. Negative 3 squared. Negative 3 squared. Okay? Those are two different problems. Here you square the 3 and you get 9. Then you bring the negative sign down. The 2 only goes to the 3. Okay? Here's just the negative sign is in parentheses with the 3 and the 2's on the outside. You're squaring the whole thing, so it's negative 3 times negative 3. That's positive 9. So it does matter whether or not you put parentheses, okay? So with that in mind, watch. This negative 3 is inside the parentheses, and this 2 is on the outside. So this negative 3, this entire thing inside the parentheses is being raised to the second power. 1 times 2 is 2. And then 2 times 2 is 4. Okay, now, negative 3 times negative 3 is positive 9. 9x to the 4th. Be very careful with your signs. Okay, number 25. Now, there's really nothing I can do here. Everything looks good. I mean, here's what I have. The problem, though, is there's nothing I can multiply, divide. There's no powers being raised to a power. But I do have a negative exponent, okay? And so if I have a negative exponent, I've got to get rid of that now. You would put the whole thing over 1. You would not move the 4. The 4 has a positive 1. You would not move the y. The y has a positive 1. You would move the x to the negative 1 down to the bottom and make it x to the positive 1. So now we have 4 to the 1, which is 4. Y to the 1, which is y, all over x. Now if you want to put the 1 here and the 1 here, that's fine, but you don't have to. So your answer is 4y over x. Alright, number 27. Now be careful on this one, okay? The 3 does not have a power of 0. The 3 has a power of 1. And they're all multiplying, don't forget. So here's what we have. We have 3 to the 1 times x to the 0 is 1. Anything to the 0 power is 1 times y to the 4th. Well, 3 to the 1 is 3. 3 times 1 is 3. So 3y to the 4th. 3y to the 4th. Moving on to number 29. Now on this one, excuse me, on this one, what we have is two bases that are being divided. Now remember, anytime you have like bases that are being divided, you write the like base. We have a base of 4 and a base of 4. So obviously we have like bases, okay? So if you have like bases being divided, you write the like base up top, and you take the top exponent of 3 minus the bottom. 3 minus 1 is 2. Nothing left on the bottom, so put a 1. 4 times 4 is 16. 16 over 1 is just 16. So the answer is 16. Okay, number 31. Okay, now here's what we have. Let's look at this very carefully, okay? Here's what we have. We have a negative 3 here, a positive 1 here, a positive 1 here, and a negative 2 here. So you do not need to move this x that has a positive 1 for a power. You do not need to move, well actually, I'm going to back up. First we're going to divide our like bases like I should have done it first, okay? So, I have an x being divided by an x. They're like bases, x divided by x. So put your like base here. Then I have negative 3 minus 1. Negative 3 minus 1, so I'll put a negative 4 here. Now I have a y divided by a y. Like bases. So whenever you're dividing like bases, you write the like base once up top. always up top, and then subtract. 1 minus a negative 2. 1 minus a negative 2, which is 1 plus 2, so you get a 3. There's nothing left in the denominator, so we'll put a 1. Now, I don't want this negative exponent, so I'm going to pick this up and bring it to the bottom and have x to the positive 4. So, my final answer is y to the third over x to the fourth. If you want to put the 1 there, you can. You don't have to. And there's the answer. Alright, number 33. Okay, now we're getting some more complex problems. Alright, look, we're multiplying two fractions together. So I'll put my fraction bar here. Here we go. My coefficient here is 1. So 6 times 1 is 6. X times x, I'm multiplying like basis, so write the base once. Add 1 and a negative 2, that's a negative 1. I have a y squared here. There's no y over here to multiply with it, so just put y squared. Now down to the denominator, there's a 1 here. 5 times 1 is 5. There's a y here, no y over here. There's an x, no x over here. So simply y x cubed. Okay? Now let's move on to my coefficients. You cannot reduce 6 and 5. There's nothing you can do, so I'll put a 6 and a 5. Here I'm dividing x into x. I'm dividing like basis right here. So whenever you're dividing like basis, put the x up top. Then you have negative 1 minus 3. Negative 1 minus 3. That's negative 4. Now we're dividing y's. Dividing like basis, y and y. When you're dividing like basis, there's a 1 here. When you're dividing like basis, you write the like base once up top. And 2 minus 1 is 1. Now, I'm almost done, but I do have a negative exponent, so we're going to bring that down to the bottom. Do not bring the 6. The 6 has a power of 1, a positive 1. Bring the x down, the 4 becomes positive. So my final answer is 6y over 5x to the fourth. 6y over 5x to the fourth. Okay, number 35. Same type of problem. Let's see if we can't solve this and make this easy for you, okay? We're going to multiply our two fractions together. We have a negative 12 times a positive 21, alright? So negative 12 times a positive 21 is negative 252. Alright, now we have an x to the 1, x to the 5th, multiplying x times an x. When you're multiplying like basis, write the base once. 1 plus 5 is 6. Multiply a y times a y. Write your like base once. Add your exponents. 1 plus 2 is 2, or 3, excuse me. Now we're going to take 7 times 4. That's 28. And then there's an x here, but no x over here. There's a y here, but no y over here. So we're just going to put x to the 4th y, okay? Now, remember with your calculator, it will reduce this for you, okay? First of all, we know that a negative over a positive makes the whole fraction negative, okay? Second of all, I'm going to type into my calculator 252 divided by 28. I'm going to hit enter, and I'll get 9. So that means 28 goes into both these numbers. 28 goes into 28 once. 28 goes to this 9 times. So 9 over 1. Now, look at my x's. I'm dividing my x's. I'm dividing like base, like base. When you're dividing like bases, write the like base up top and subtract your exponent. 6 minus 4 is 2. We're dividing like bases right here. When you're dividing like bases, write the base once and subtract 3 minus 1 is 2. Okay? So anything over 1 is just itself, so really your final answer is negative 9 x squared y squared. Negative 9 x squared y squared. And lastly, number 37. We're going to multiply top times the top. You have a coefficient of 1 here. 1 times 20 is 20. You have a y here, no y over here, an x here, no x over here. So x to the 14th, y to the 10th. Alright, then we have 2 times 1. 2 times 1 is 2. X times x. When you're multiplying like bases, write the base once. 3 plus 1 is 4. Here's a y, there's no y over here, so bring down your y. Now, let's simplify this. 2 and 20. 2 goes into 2 once, 2 goes into 20 10 times. So we have a 10 and a 1. X divided by X, write your like base ones up top. 14 minus 4 is 10. Y divided by Y, write your base ones. 10 minus 6 is 4. Okay? Everything over 1, so our answer is just 10. X to the 10th, Y to the 4th. Okay? Hope that makes sense. Alright, now, on to some more challenging problems. I know that when I taught you, I did not give you any equations, but that's okay. This is good common sense reasoning, okay? So let's see if we can't solve some of these. Alright, here we go. I would not hesitate to give some problems like this to you on a quiz, so make sure you pay attention and think this through now. Good, wholesome common sense, okay? What number could you put in for 4 here that would give you 1/4? Well, think about it, guys. Come on. If I put a 4 right here for X, I would have 4 to the what? -1, right? Now, what is 4 to the -1? Let's work that out over here. 4 to the -1 is really 4 to the -1 over what? 1, right? Now, if I don't want this negative exponent, I pick up my 4 and I bring it down to the bottom here. And I have 4 to the +1. There's nothing left up top, so I put a 1. So I have 1 over 1 times 4, which is 1/4. So 4 to the -1 is 1/4. So if I put 4 in for X, then I get 1/4. So X equals 4. That's the answer. Now, hold on. Mr. Earhart, how'd you know to pick 4? I gotcha. I understand that. Look at it like this, okay? Another way to look at solving this is simply like this. Notice how I have a negative exponent over here and I don't have 1 over here. So I would recommend that you take the right side and realize there's a 1 right here. Bring the 4 up top, and when you bring the 4 up top, you have already a 1 up top. So 1 times 4 to the -1. Got it? All over 1. I brought the 4 up top, okay? Now, 4 to the I'm sorry, 1 times anything is just itself. And anything over 1 is just itself, so I have 4 to the -1. Now come over here and bring this down. X to the -1. So look, guys, I have a -1 here, a -1 here. It's obvious X has to be what right here? 4. Put a 4 in for X. 4 to the -1 equals 4 to the -1. X equals 4. Guys, you gotta think deeply on these. There's no steps that I can give you. You gotta think deeply and really work hard on this, okay? Alright, number 45. Now before you start solving, number 43, before you start solving this, I would, first of all, simplify this over here, okay? So here we go. Let's simplify this left side. X squared times 1 is X squared, okay? 3 times X is 3X. Now, next, students, continue to use your exponential properties I taught you in the lesson. Normally, you don't want to divide by an X, but in this case, we're just going to use the properties they taught us. So I have a 1 right here. Okay, so I have 1 over 3. X divided by X, write your like base here. Subtract 2 minus 1 is 1. So I have 1 X to the 1. Well, that's the same thing as X over 3. If you want to put the 1 here and the 1 here, that's fine. There's no need to. Okay? So does everybody see what I've done so far? I just simply multiplied these two together. Then simplified, now I have this. Well, guys, you know what to do. What is the 3 doing to the X? Dividing. So multiply both sides by 3. Multiply this side by 3. Multiply this side by 3. These cancel. 4 times 3 is 12. I don't have the answer up here, but the answer is 12, okay? Alright, moving on to number 45. Now, same thing, guys. Let's first of all simplify this left side over here, okay? So here we go. Let's multiply these two fractions together. I have a 1 here. 1 times 3 is 3. There's X here, no X here, Y here, no Y here. So X to the 16, Y squared. There's a 1 right here. 2 times 1 is 2. X to the 12 times X to the third, multiplying like base bases, add your exponents. X to the 15, y to the 1 times y to the 1. Y times y would be y squared. All of that, of course, equals 9 halves. Now, let's simplify a little more. 3 over 2 cannot be reduced. Okay? However, look at your x's. X divided by x, when you're dividing like bases, you write the like base once up top. Subtract the exponents. X to the 1 is just x. Look at this. Y squared divided by y squared, dividing like bases, write your like base here. 2 minus 2 is 0. So we know that's going to be a 1. So we really have this. Let's look at it up here. You have 3 times what? X. Times what? What's y to the 0? 1. All over what? 2. Okay? Well, 3 times 1 times x is just 3x. So I have 3x over 2. So all of this equals 3x over 2 equals 9 halves. Guys, we know how to solve this. This is like an old linear equation we did in the first chapter this year. Okay? You have 2 and a 2 for your denominators. So let's multiply the entire equation by 2 over 1. 2 times 3x over 2, your 2's cancel, leaving you with 3x. 2 over 1 times 9 over 2, your 2's would cancel, leaving you with 9. Divide both sides by 3, and x equals 3. And lastly, number 47. Okay, let's first of all simplify. Okay, so let's put this over 1. Put that over 1 so we can multiply our two fractions, okay? So, 2 times 25 is 50. K to the 1 times k to the 1 is k squared. X to the 4th times x to the negative 1, multiplying like bases. Write your base ones. Add your exponents. 4 plus negative 1 is 3. Moving on. Now we're going to take this times 1. Anything times 1 is just itself. So I have 5k squared x equals 1/10. Okay? Now, let's simplify this left side. 5 goes into both of these numbers. So I'm left with 10 over 1. K squared over k squared, they really cancel out is what happens, guys. So, I mean, back here in the last problem, when you had y squared, here it is, when you had y squared over y squared, I made it y to the 0, and then put a 1 in, and that's fine, but to make it a little faster, they really just cancel out, okay? Same thing, so your k squares cancel out. Now watch this carefully, you have x to the cubed divided by x to the 1, okay? When you're dividing like bases, you write the like base ones up top. 3 minus 1 is 2. So 10x squared over 1 is just 10x squared equals 1/10. Now, I hope you guys have not forgotten everything you learned last semester. We call this a quadratic equation, right? Sure we do. Quadratic equation, okay? And you know that when you have an x squared term with no x term, you can actually just get x squared by itself, remember, and take the square root of both sides. It's called the square root method. Remember, the square root method only works when you do not have an x term or a b term, whatever you want to call it. It's the same thing. Well, I don't have an x term, I have an x squared term. I do not have an x term, okay? So, I'm going to get the x squared by itself, divide both sides by 10. Alright, these cancel, leave you x squared. And 1/10 divided by 10 is 1 over 100. 1/10 divided by 10 is 1 over 100. Now, take the square root of this side and the square root of this side. The square root of x squared is x. Now the square root of 1 over, and don't forget to put plus minus. The square root of 1 is 1, right? 1 times 1 is 1. And the square root of 100 is 10. 10 times 10 is 100. So there's your answer. Positive negative 1/10. I know these are pretty tough equations, but you can do these, and there's really no teaching to have taught you in your notes. It's just basically taking the exponential properties, simplifying, and then solving the equation. Okay, I hope this homework help video has been a help to you. If you have any questions, don't